Okay, so here we're going to look at the 2016 Ordinary Level question B-1 on Axonometric Projection. So we're given a USB stick and we need to draw it in isometric using the Axonometric Projection method. So we need to construct what we're given, the plan view, the elevation, which is a little bit inclined, so we can't use our traditional set squares, we have to use sliding set squares, and then we're going to bring down all our points to find the axonometric projection. So first off, what I'm going to do is I'm going to set up, and I'm going to complete part A. I'm going to draw the given triangle here, and I'm going to construct the axonometric axis x, y, and z. So I'm going to first off start off with x, y, and z. If you need to take a screen grab, do so now. I'm going to construct these axes because it's in axonometric. Sorry about that. We're going to do it at 30 degrees, so I'm going to first off construct my y-axis and draw it in a bit heavier. There we go. I'm going to construct now my z-axis. I'll label that over here, z, and my x-axis. And here is my y-axis. I'm then going to construct the plan that we were given. Oh, sorry, no, I'm not. I'm going to construct my equilateral triangle by. You can see that the length of the base of that equilateral triangle is 100 millimeters. So I'm just going to find that equilateral triangle on the axes. So bring it up to cut the x, y axis, or the x axis, and now I have the base of that equilateral triangle. I'm going to construct the rest of it using my 60-degree set square. And now I'm being given the points A, B, and C. Now I'm not going to label C because it's going to get in the way, but C is just here. So now I'm going to construct the plan that we were given. So let's see here. I'm going to drop down points A, B, and C. We're going to get this horizontal line here, and we're going to construct this semicircle to find this point here on the C line that's been projected down. So let's do that. So drop down all 3 points. You can't really see that. So I've drawn a horizontal line. I'm now going to construct my semicircle using the center point. And if you've done this accurately, this line here should be at 45 degrees. You can extend it further if you need to, and the same on this side here. And I can construct my plan to the given dimensions. So I'm just going to do that. There we go, our plan is complete. Now I'm going to construct the elevation by projecting up points A, B, and C and parallel to the z-axis, so at 30 degrees. Let's move the camera so you can see. Again, construct the line parallel to the line BC. So we constructed a parallel to the line AB down in plan. So this line here was parallel to the line AB. Now we're going to do the same with the line BC up here. Construct our semicircle. And we'll find our two lines. So this here will be basically an XY line, because it will be showing the ground plane, the horizontal plane, sorry. And there we go. Now I can construct my elevation so I know the length of it. This way, or the width of the USB is 40 millimeters. I'm going to need the center point. So all the measurements for this are on the sheet. And I'm going to measure my heights as well. So I'm going to need my height to the center point of the semicircle at the top, which is 90 millimeters. And I need to come up then 50 millimeters. Also, I'm going to use slide and set squares now to draw some parallel lines to the horizontal plane. T-squares in the way. Can draw this in heavy now. Oops, too far down. I should have stopped there. Find the center point, but coming in to the midpoint. And I'll draw my semicircle here. Like that. Now I'm going to start with this top body here, so this cuboid shape here. I'm going to find this body and then I'm going to find the bottom. And it doesn't really matter where you start, sometimes I start at the bottom. But it's fairly easy to find each point, so I'm going to start with this point here. I'm going to find this point down in the isometric, and I'm just going to make sure we can see the plan also. So I'm going to project it down 30 degrees, and I'm going to find that point down in plan, so that point will be here and here. So I'm going to project it up. Found one of them, and the second one. And I can draw that line in. I'm now going to find this point, project that off, and bring it down to 30. There we go. And now I can find where the cuboid meets this cylindrical body. So I'm going to bring down these points, and we'll go up to hit them there. There we go. And now I can find the bottom points. So if I bring down the bottom 2 points and these two and project them up, so I'm going to be using the hidden detail here. find the first point, second point, and the final point. And there's the USB port part. Now I can find the curve section, so what I'm going to do is I'm going to actually divide this up into 30-60 divisions. So to do that, I'm going to set myself up with sliding set squares, and I'm going to move this down. This clip might actually be in my way, so hopefully this works out okay. I'm going to set that up parallel. Drop it down, and then I can come up at 30 degrees, 60 degrees, 60 degrees, and 30 degrees. I'll also find the very top of the midpoint of the curve to come up at 90 degrees. So now I have point 1, 2, 3, 4, 5, 6, and 7. And I can find them now in plan. So if I just join points 2 and 6 lightly, and points 3 and 5, we will get these widths here, or this length here. So I'm going to call the length from 3 to this center point here, L1. And I'll call the length from 6, L2. So I'm going to start by finding points 1, 4, and 7, because I already have them. So 1, 4, and 7 in plan. If I move it back, so there we go. So 4 will be dead center, so I have 4. 1 will be over here on the left, and 7 will be down here on the right. To find point 3, I'm going to measure out from the center point this L1 distance. So if I take that on my compass, like this, and step it out from the center line, like that. Do the same the other way. I've now got point 3 on this side, and point 5 on this side. I can find point 2 and point 6 by taking the L2 distance. And stepping out the same way. Point 6 and point 2. And now I can find them up in my isometric. So point 7 is already here. Point 1 is there. And I can find point 4 quite easily by projecting down point 4. And it will be right there on that line that projects up. Yep, I've done it accurately. Yep. So now I have point 4. I'm not going to label, I will label point 4. And now I'm going to find point 6 by bringing it down and bringing it up to intersect. Point 6 has come down, and I can bring this up now to meet. And there it is. I'll bring up point 5 now while I'm at it, and bring point 5 down to meet. And double checking I have the right one. Yep. So now I have 4, 5, 6, 7. I do the same out to find points 2 and 3. So they're actually basically on the same line. So I don't need to bring down point 2 as well. Project up point 3. Find it there. And point 2. Just there. And I can draw that curve in now freehand, as neatly as possible. go. And it's the same process on the back curve. So I'm going to project back my points onto the back edge of this USB stick. So I have my point 2 on the back there, point 3, point 4, 5, 6, and we already have point 7 just here. So now it's just a matter of projecting up each of these points. So point 6, bring it up, and it'll be on the point 6 line, just there. Point 5 will be on the point 5 line. 4 will be on the center line. 3 here. And if I find point 2, you'll see that it actually goes below the curve. What I mean by that is if I join this here in a tangent, you see that point basically joins there. I can just finish off my curve. We have the axonometric finished. Hopefully that helped. Thanks.